Brilliant. Well, welcome everybody to our November lecture. So I'm very pleased tonight to invite to speak with us Professor Prof Lovelock, a global expert on the impacts of climate change on coastal wetlands and on the role of coastal ecosystems in mitigating climate change or blue carbon. I'm sure we're excited to find out more. Thank you, Professor Lovelock.
Well, thank you, John. And hello to everybody online and hello to everybody in the room. Thank you for coming. I'm delighted to be here and thanks for the invitation, Lilia and John. Okay, so I'm a professor in the School of Biological Sciences, right? But I have a broad interest in coastal wetlands, and I've got a picture of one here. This is from Gari or Fraser Island, the mangroves, and there's also some salt marsh in there as well. But tonight, this evening I decided to talk to you a bit about coastal wetlands and their role in climate change mitigation and also adaptation. I'm going to spend a little bit of time on adaptation and most of the time on the climate change mitigation or their role in sequestering carbon. And I suppose that's particularly important at the moment as we are watching the Conference of the Parties in Glasgow and thinking about how we are going to reduce our CO2 emissions into the atmosphere. Okay, so I needed to define a couple of terms first, just in case just so that we're all understanding what I'm talking about. Adaptation, I'm talking about the process of adjusting to current or expected climate change and its effects, right? So it's one of the ways we can respond to climate change along with mitigation, and I'll define that in a moment. And the example for that is when we have, urban heat stress and heat associated with, a lot of concrete and built environments. One of the adaptations to that is to expand green spaces within urban footprints. So the other term I use is mitigation. And by that, I mean it's the reduction of something harmful and the reduction of its harmful effects. And what I'm talking about here in terms of mitigation is helping with the harmful effects of the increases in CO2 in carbon dioxide over time. So this is the plot that I'm sure many of you have seen before. So this is carbon dioxide in parts per million in the atmosphere versus years 1960, it's below 320. We're now tracking at over 450. So, when I first started doing science, I used to measure photosynthesis, right? And I used to have machines and we would set the CO2 concentration. So even, within my career, I started here when we were setting the machines at about 350. And now we're, a long way past that, right? So this jagged part, of course, this up and down is the seasonal uptake of carbon dioxide by plants in the northern hemisphere summer, and then the drop is as that productivity declines, and it's really influenced by the northern hemisphere because there's so much land mass in the northern hemisphere compared to the southern hemisphere, which is largely ocean, apart from Australia and a few other bits and bobs, right? Okay, so what I'm going to talk to you tonight about is the role of coastal wetlands in adaptation to climate change. And then I'm going to focus on this blue carbon part, which has become something that a lot of people are interested in for various reasons, in that we need to reduce our CO2 in the atmosphere, and this is one way to assist in doing that. And then, in order to do that, we have to do conservation and restoration of coastal wetlands. So I'm going to talk a little bit about that and some of the challenges and ways to get over that that are currently being developed. So first off, I'd say that coasts are, I just wanted to, dwell on the fact that coastlines are exposed to climate change. So I don't know whether anybody wants to have a stab at where this is. But, we've got cyclones in much of parts of Australia and other parts of the world. Coastal flooding, this is an example of coastal flooding. Sea level rise, often we have extreme events and extreme sea levels at the same time. We have coastal inundation. And then, some of the other things that occur are like things like marine heat waves. And they have been becoming more frequent. And in that you would, put in that basket, the warm water that sits on the Great Barrier Reef that causes bleaching, the big dieback of seagrass that we had in Shark Bay and West Coast, and the loss of kelp in other places, so marine heat waves are usually a big deal for the biota that's in the water, right? But mostly, this is actually in Brisbane, on the coast, Manly somewhere, right? One of those big tides. So I think it's sort of like an indication of the vulnerability of the coastal lands in which we live. So there's a lot of pressures on coasts as well. Agriculture and aquaculture, two big ones. There's urban development. This is Brisbane Airport, of course. And then industry. This is a photo from saltworks in the Pilbara in Western Australia. So, there's these climate change impacts on coasts, and then there's also these, big human impacts on coasts as we use them. So what's happened with all of that? Not so much climate change yet, but the human part is that there's been a lot of degradation of coastal wetlands. So this is a mangrove, or was a mangrove in Madagascar, which has been harvested for charcoal. This is sort of like the fate of mangroves in many parts of the world, right? So about half the distribution, or half the area of mangroves in the world, have been removed, right? So they've been lost. And you can imagine that has come with significant carbon dioxide emissions, And this is the soil used to be up to here, right, on this tree. And they've lost all of this soil, and that soil is extremely carbon rich, and so it's led to emissions. So it's not only mangroves, though. Seagrasses have been influenced and are currently negatively influenced by poor water quality. So seagrass, they're photosynthetic plants, but they're in the water and they need light. And if the water is too turbid, then there's not enough light and they die, right? So seagrass globally is still being lost at a really pretty high rate as water quality in the coastal zone is poor, right? So that's another one. And then probably one that, I think about a lot is the conversion of coastal wetlands to agriculture for food production. I think about that a lot because that's what's happening in Queensland a lot, and throughout actually the southeast and the southwest. So, in this case, this is a ponded pasture. There's a bund wall, and they keep the tide out and flood it with fresh water from behind and grow pasture there so that you can feed cattle into the dry season, right? So it's a pretty common use. So the thing about creating these great big freshwater systems is they actually emit methane and nitrous oxides, which have very high global warming potential. And then probably this is the big one for mangroves. This is shrimp aquaculture. So throughout Southeast Asia, mangroves have been converted to shrimp ponds. And this has been largely to support economic development. So the taste for shrimp, in big markets like the USA and China and Japan, have driven this expansion of this industry that has been completely at the expense of the mangroves and therefore the artisanal fishery, the natural fisheries, right? So, I'd add conversion to land use there, but this is the shrimp production, since 1985 for these large shrimp producing nations. And you can see that, it's an enormous impact and an enormous impact on the coastal zone. All right. So that's sort of the background to, what's happening in the coastal zone. And then I want to focus on the ecosystem. We've talked about seagrass, mangroves, and salt marshes. And this is a salt marsh. This is a local salt marsh. This is Tinchitamba Reserve in Brizzy, where I've got a number of sites. I love it. And this is actually Low Isles, so off Port Douglas. So anyway, coastal wetlands, they're comprised of these angiosperms, flowering plants, And they're unique in that they tolerate either being submerged by seawater or sometimes submerged by seawater. So they can tolerate inundation and salt, right? And you think about that is remarkable for higher plants because, you know, I always, when I'm talking about this to my students, I think, imagine how many millions of dollars have been spent trying to develop salt-tolerant rice and salt-tolerant wheat, you know. It's a huge job and it really can't be done very well, and yet these plants have managed to do it, and this is like millions of years of evolution. And in fact, only a few, really relative to the, say, for example, the diversity of the rainforest, there's actually very few plant species that make it into the marine environment because it's such a tough job, right? They've evolved this incredible suite of specialised characteristics to be able to grow in those conditions. One of those is inundated soils. They are, you know, they have specialised root systems and all manner of ways of dealing with salt and inundation. But one thing that occurs under all of them because of this is that there's an accumulation of carbon in the sediments of the soils. That's because they're really highly productive and they're shoving a lot of their biomass below ground to root systems. And then under the soil that's wet, decomposition occurs very, very slowly. And so over time, carbon deposits increase, right? So basically you have a system that's growing a great big wad of carbon-rich sediment, right? And that's really underlies their function and as carbon sinks. So per hectare, like for each given area, you know, mangrove forest, this is their above ground biomass, their below ground biomass, and then the soil. They actually hold more carbon, you know, per unit area than tropical forests. And this is a swamp forest, so a freshwater swamp forest, which isn't bad. And this is a subtropical tidal marsh, and then seagrass. Seagrass has much less sort of carbon per area, but seagrasses are much more extensive than mangroves or tidal marshes. You know, the seagrass global extent might reach 600,000 kilometres squared, while the mangroves at the moment are about 135,000 kilometres squared. Okay, so we've got a lot of these ecosystems in Australia, right, relative to other countries, mainly because we're a continent, right, and with a big shoreline. So, you know, the marshes actually are almost around the whole of Australia, with the exception of the bits that are very steep, you know, so the bite, you know, big cliffs and that kind of stuff, but, you know, really extensive everywhere. The mangroves mostly in the north, but of course we do have mangroves all the way around to, you know, the most southern mangroves are in Corner Inlet. It's fun, you know, it's like little teeny mangroves and wombats down there in the Corner Inlet. Very nice, very fun. And then seagrass, of course, is on all of the, you know, most of the relatively sheltered shores around Australia. All three systems, you know, are low energy, as in, you know, you never find them on a wave-swept beach, for example. It's always sort of low energy, like the inside of Moreton Bay, not the outside, right? Because they've all got roots and they get ripped up by wave energy if there's too much. Anyway, we've got a lot of this, and they vary in characteristics depending on the climate. You know, we've got everything from temperate seagrass to the most tropical looking mangrove forests. You know? Okay. All right, so now that's the background, and we're going to talk a little bit about their contributions to coastal adaptation. So one thing, I'll just run through the list and then I've got a few examples for you. So protection from storms and by reducing the impacts of waves and storm surges. So this is a function that's particularly important where you have infrastructure that is wave exposed, you know, during storms, right? So in those cases, then, you know, a mangrove in front offers a lot of resistance to those waves. Basically, they've got all of that structure, you know, and they dampen the energy as it comes shoreward. Right? Sometimes if you have these ecosystems in series, like you'll have a coral reef, seagrass meadows, salt marsh, or a mangrove, you get even more protection, right? Because each step of the way, the ecosystem basically dampens the waves. Some of the numbers are global flood damage. You know, they estimate maybe there's 52 billion in annual damages that can be avoided or are avoided because of the role of ecosystems in preventing that kind of storm and flood damage. One thing that I spend a lot of time measuring is that actually increasing the level of the sediment, right? So this accumulation of material that basically keeps the level of the sediment keeping up with sea level rise, right? So they basically grow sediment at, you know, 3 millimetres a year. It's a little bit like watching paint dry. I've got a slide for you about how we do that, but nonetheless, pretty cool. And one of the other things is that rather than hard infrastructure, coastal wetlands have the capacity to repair and adapt, right? So they add sediment, they can regrow if they're damaged. And some of the arguments go, you know, if you build a seawall, eventually you have to raise it, right? Because sea level is going to be a metre higher in at least by 2100, right? So we're going to have to raise the seawalls if we want to keep them. But the thing about coastal wetlands is that they actually can do it themselves under the right conditions. And then, you know, compared to that sort of hard infrastructure, they're actually, you know, relatively inexpensive, and they have additional, what we tend to call co-benefits. But by that, I mean mud crabs and barramundi and birds and water quality enhancement and all those other good things that happen is when you have coastal wetlands in your coastal system. Because the picture says here, when we have nothing, you know, on our coasts, we have a lot of erosion, we have turbidity, we have high wave energy and rapid fluxes of water off the land, right? And when we have a lot of vegetation on the landscape and other things in the water, we can dampen waves, we can trap sediment, we can prevent nutrients reaching the ocean, right? So all in all, very important in buffering the effects of climate change and also other anthropogenic kinds of effects. So this is the example I have for you, and I have this because, I mean, you are geographers and you like maps, right? So I feel obligated to provide some sort of large geography sort of thing. So this is a study by my colleague Edward Barbier, and he uses something that a lot of people have started to use as a source of data, and that is night lights and the intensity of the nighttime lights that you can see from satellites, right? So he uses that. He's actually an economist. So lights tell you about economic activity. And we all know that because we look at parts of the landscape that have no lights at night, North Korea, for example, or have very limited light, which is an indication of their very low level of economic activity. Okay, so what he did was he looked at the night lights before and after big cyclones and in sites that have mangroves and those that don't, right? So you can imagine that's a big data trawl. And you notice that he's the last author probably because his student did all the grunt work here, maybe. Okay, so this is the trends in economic activity. It's sort of like a unitless kind of, you know, axis comparative, right? So we start at 0, and these are places in red that have only 6.3 metres of mangrove per metre of coastline. So like that means that the stands are only 6 metres wide at most, just a few trees on the edges of things. And then this is if you have more than 25 metres, right? So the error about them, there's a lot of error. But, you know, the storm comes here and you see a decline in economic activity in areas that don't have much mangrove, and you see less of a decline where you have more mangrove. And he does this mostly for developing nations. And, you know, because they basically, you know, in his analysis, you can see that the effects of cyclones are actually greater on developing nations because they don't have the hard infrastructure as well as the soft infrastructure, and often the mangroves have been damaged. Okay, so that's my story about storm protection and how it's important for economies, and that's one way you can value coastal wetland. You know, you can actually put a monetary value because you avoided those insurance claims and you don't have to reconstitute your, you know, all of your stuff that's in the way of the flood and the cyclone. So one thing that I do actually is spend a lot of time looking at this increase in the elevation of the surface of wetlands, right? So this is me measuring my surface elevation tables. This is the surface elevation table measuring the height of the surface. And I do this annually in a whole range of places. These are all of the sites that have these instruments. So these are instruments that were developed by the United States Geological Survey. And so we have, you know, I have 36 in Moreton Bay, another 15 up at the Daintree. Actually, it might be 18, a bunch in Western Australia, you know, the Southwest. Some colleagues have them in Adelaide, you know, so we're all using this very similar technique. And we're measuring, what we've done is we've hammered a post all the way down so it can't move anymore. So the deepest one I have is 17 metres. Right, so this is 17 metres of stainless steel rod that you smash in. Then you put this thing on the top and you leave it there, and you come back every year and you measure with these pins relative to that bit that's stuck in the soil, it's not moving anywhere, right? So that means I can measure to millimetre accuracy what's happening. So this is in Exmouth. Believe me, not a lot happens there. But, you know, I measured the ones just recently here in Western Australia, and they're gaining somewhere between 3 and 6 millimetres a year, right? So they're, you know, growing. The ones I put in Moreton Bay are, I put them in 2007, and the last estimate, they've gained 7.5 centimetres over that period of time, right? So they're growing in height, you know, growing in soil volume, right? And the rate of sea level rise at the moment is about 3 mils a year. So some of them are definitely, you know, making enough elevation gain to keep pace with sea level, and some of them are not, right? And that's the interesting thing about where are they safe and where are they failing to keep pace? Because those that are failing to keep pace will eventually drown, right? And they'll turn into something else, whether it's open water or seagrass or something. Okay? So I spend a lot of time doing this, and yeah, this is the part that's a little bit like watching paint dry, but it's worth it in the long run. I can't tell you how happy I am when I watch those trajectories over time to work out who's doing what. But what we notice actually through doing this globally is that in a lot of places there's a lot of subsidence, and that can be due to groundwater extraction or other, you know, maybe just compaction of the soils. But there's still a lot to work out. All right, I'm going to leave that because I really want to talk a lot more about blue carbon. So blue carbon, this is the part about mitigation. And it's a funny term because mostly all you've seen so far is actually brown dirt, right? Brown soil. And it's interesting because blue carbon was a term coined in about 2009 in this report. And they really started to talk about it to draw attention to how important marine ecosystems are in capturing carbon from the atmosphere and storing it away, and what damage people have been doing to oceanic ecosystems. And I went through that in the beginning, what's been happening to coastal wetlands, right? And people just haven't been paying enough attention to, what is happening, right? So, more generally, blue carbon is sort of every bit of carbon that ends up in the ocean or marine ecosystems. But there's been this focus on coastal wetlands because of that high concentration of organic carbon that's held in the sediments and the biomass, and because they've been converted and degraded, and because we can manage that to enhance carbon sequestration. Right? These are absolutely manageable problems, and we can increase carbon capture into those ecosystems if we can restore them, if we can conserve them. Right? So really the whole game here is that we're talking about carbon because that is important, but what we're trying to do is basically revitalise the coasts to produce all of these things that people get from coastal wetlands. And we would have fisheries and shoreline stabilisation and coastal protection and water quality maintenance and timber and recreation and habitat, all of those things. So carbon is like the extra bit, and then all of those other things are the co-benefits, but really it's sort of a bit flipped, I would say. But governments are more interested in climate change mitigation than they are often in biodiversity. It's probably the truth. All right, so this is the way it works. Blue carbon is all about incentives for restoring and conserving wetlands. So if we have intact wetlands, they are net greenhouse gas sinks. They take carbon dioxide out of the atmosphere in photosynthesis, and they put it to their roots and soils, and it stays there for millennia, right? So it's good. So we've got a sink. But as we degrade it, we end up with CO2 emissions. So if we can do more conservation, we can actually avoid those CO2 emissions. These alternative land uses, things like aquaculture, flooded agriculture, draining soils, all these things, they actually have net greenhouse gas emissions, and some of those are methane and nitrous oxide, which have very high warming potential, right? So the idea here is if we can restore them, we can resume these carbon sinks, okay? Now, I know that, you're all probably aware that there are markets for carbon dioxide, right? So companies pay people to grow trees to fix carbon dioxide, and there's regulations about how many emissions you can have, right? And if you exceed those, then you have to offset them, right? So there's a whole market around carbon and carbon dioxide that can be, that these sorts of projects, restoration or conservation, might access to fund them, right? So carbon dioxide and understanding the carbon dioxide fluxes and also the fluxes of greenhouse gases is an important sort of step to generating finance for conservation and restoration. So somebody always asks me, so these are very small, these are, systems that are like around the edges of continents compared to the savanna of Australia. These are tiny areas. They have very high carbon capture potential, but they're tiny. So what can they do for the world, right? How much of the CO2 that's in the atmosphere can they take out to help us keep at 1.5 degrees? And the truth is not much, about 2% if we do really well at conservation and restoration. So not much is a relative thing, because this is some calculations about all of the actions that you might take in the oceans to reduce CO2 emissions to the atmosphere. And this is the coastal wetland part. But, at this stage, it's kind of like we need every option, right? And coastal wetlands provide an option that gives you a lot of other benefits. Additionally, 2.5% of global needs, but if you're Indonesia or Bangladesh or Belize, you have your coastal wetlands, and what they can do for climate change mitigation is actually a significant portion of the national emissions, right? Because they have low emissions in industrial sectors. They've got a lot of opportunity for blue carbon to store carbon. Okay. So one of the, looking for a time. The big question then becomes, how are we going to achieve this? Like, if we think that coastal wetlands are so good for climate change adaptation and mitigation, what can we do, And we need to provide these incentives for governments, for industry, for landholders, particularly in communities, to do conservation and restoration of their coastal wetlands. It's an easy thing to say, but it's actually really hard to, get that whole train moving, if you like. It's really quite difficult. We need to provide livelihoods, for people who cut down the mangroves so that they can cook, like people in Myanmar and various other countries in the world. Then, we have to find something to replace that for a start, right? We might have to capacity build, so we might have to do a lot of teaching about the importance of these ecosystems and why you want to keep them, although many people already understand that. We need financial resources. So, we've talked about in Australia, there's been proposals for carbon taxes, but there are also things like debt swaps. So, let's make an example. Some small island state who's in debt might say, I'll do big, conservation action on for the CO2 emissions, and we'll swap that out for my debt, with another country. Let's say Norway or somebody else who does that sort of thing. There's insurance companies, green bonds, other ways. So one thing that's also that I've been involved in a lot is enhancing the guidance of how you might count the carbon in coastal wetlands, because that's not simple either. You need to count it and then you need to verify it, right? So we've been doing quite a lot of that kind of work. Right? So I suppose I've got this picture here, and this is a picture of a mangrove in Vietnam, right? So in Vietnam, the mangroves were destroyed. The mangroves of the Mekong Delta were destroyed by Agent Orange in the Vietnam War, right? Because the Vietnamese moved in the mangroves, and they were very difficult to, and mangroves are hard to work in, right? I don't know if you've ever been to walk in a mangrove, but it's actually pretty hard to work in sometimes. And so they, removed them all, right? And then the Americans actually had a plan to restore or try. They recognised the damage that had been done, right? People were starving because there's no more fish. The rivers aren't navigable anymore. There's it's total devastation, right? So the Americans had a plan to revegetate, and they had actually started doing experiments like dropping mangroves out of helicopters in Florida in preparation for this, right? But then it didn't work out that way. And in the end, the Vietnamese restored it. And this is a part of the restoration. And this is probably the biggest restoration that's ever happened, in one area of an ecosystem, right? So the Vietnamese, mainly children and women, took this on, and they replanted the mangroves of the Mekong Delta, which is sort of astonishing. But that whole interest in restoration actually grew out of that, right? So now one of the biggest restoration industries for salt marshes and mangroves is out of Florida, right? Because they really developed all these techniques and, started to think about it, and they started to restore the mangroves also in Florida where they've been damaged. Anyway, that's a story about how it's feasible. There's lots of examples to show that restoration of what we've lost is feasible. Okay, but one of the things that really bothers everybody about doing particularly restoration projects is that there's a lot of uncertainties involved, right? Because people, are uncertain about what the outcomes are going to be. They're uncertain about how much it's going to cost. It's still really a growing industry or really a growing field, right? So, doing demonstration projects are really important. And in Southeast Queensland, we actually have a lot of coastal wetland restoration that's gone on. And one of the big, this is a picture this is the restored part and the unrestored part down in the Gold Coast, right? So the Pimpama River has had some big restoration projects in it, right? And the Land Restoration Fund of the Queensland Government, which is their new fund to support restoration of natural ecosystems in Queensland. It's a $500 million commitment that's being spread among a whole range of projects to enhance carbon sequestration, so they're carbon projects, but through the federal government, but they are paying into those projects for those other benefits, like water quality and biodiversity and other things. So the Land Restoration Fund is supporting a couple of pilot blue carbon projects. So when I mean blue carbon projects, I mean where they have a land use, let's say it's old sugarcane land, and you do a restoration, you grow a mangrove, and you get to count that carbon, receive Australian carbon credit units for it, which you can sell. Right? So you do the project, maybe it costs you $50,000, and you store carbon over 25 years, and you will get, whatever you negotiate for that carbon credit back to you, which you can sell on, right? So it's a way of raising money for restoration and conservation. Okay, so one of the big projects that's underway, I'm not certain whether anybody's heard of it, is the Blue Heart Partnership. So this is the Sunshine Coast. I love this one because it's big, and it's sort of, they call it the heart because this is only half of it, but it sort of covers sort of a very heart shape in the middle of the Sunshine Coast, and this is the Marichi River, right? So it's about 5,000 hectares in total, sitting near Yandina, right? And it's a partnership because Unity Water, which is the water utility up there, so they bought this part, which is an old cane farm, which they have restored to coastal wetlands, and they did that for a nutrient offset, right? Basically, they had they needed something more to accumulate to treat nutrients than their sewage treatment plant. They don't need it yet, but they need it in the future. That's the way I understand it. It's a buffer, right? So they bought this for a nutrient offset, and then the Sunshine Coast Council has been buying bits of land around the place as well, right? So this is sugarcane land that is incredibly low elevation. It's been drained. There's some fantastic geographical literature on the drainage of Queensland wetlands for sugarcane. And this is one of the big areas where it occurred. But as you all know, the sugarcane production is declining, and the mills are actually having trouble meeting their capacity, right? So there's a lot of land, and land is becoming more attractive to not agricultural purposes. Anyway, there's changes afoot, social changes as well in the region. So the Unity Water's got the centre part. The Sunshine Coast Council is buying all bits and pieces around, and they are a lot of them have already been sort of partially restored to coastal wetlands, and some of it is still yet to be restored. And it's this block here that is going to be a pilot blue carbon project, right? So we're joining with the state government and also the federal government to try and generate carbon credits. And it's not only, though, the carbon that's of interest. Of course, everybody's interested in these other services. And I have to put in here that the Kabi Indigenous people of the region are also extremely kind of interested in this restoration of the Maroochy River to its prior kind of beauty. All right, so why we can do a pilot carbon project is because there is a way to measure carbon that is coming, right? So for the last year or more than a year, I feel like sometimes it's my lifetime, but we've been working on a method under the Emission Reduction Fund, which is Australia's carbon market, to introduce so that we can do these restoration projects and gain carbon credits, right? So that's something that we hope is going to be released in November the 25th. So after that date, people who want to do carbon projects by restoring coastal wetlands will be able to do them if they follow the method. Now, that's the big if, right? Because it's not all that simple. I also want to say that, you know, the International Panel for Climate Change provided guidance to countries in 2014. So we're actually, you know, slowly sort of catching up to that process. And then the Australian government also supports the International Partnership for Blue Carbon. So I think after Saturday, you'll probably hear how much the government is going to put into these sorts of things to capacity build on blue carbon for the Pacific. Right, so I think that's going to be something that we'll hear something about next week, maybe. So if we think about the land that is likely to be suitable, so I have to say this method that has been developed is about reintroducing tidal flows into land where it's been excluded. So this is about letting, this is really about sort of, you know, planning for sea level rise and getting ahead of it, really, and growing coastal wetlands where they once were, but where agriculture has been in place for, you know, 50 to 100 years. And I would say that we're not really, you know, like prime agricultural land. No carbon project is ever going to take that, right? Because that's too important. And farmers are not crazy, right? So they, you know, this is for the parts of the landscape that are degraded, that can be put to basically better use by reintroducing tidal flows. So if we think generally about the kind of land that's likely to be suitable, it'll be low elevation, lower than the highest astronomical tide plus a metre. That's the sea level rise in envelope for 2100. It'll probably be previously coastal wetlands. And why we're so lucky in Queensland is that we have an indication, it's mapped by the government, what were prior coastal wetlands. Right? We know about where they are. The pre-clearing vegetation mapping in Queensland is awesome. We know where tidal flows have been altered more or less. There are maps of, you know, tidal gates and barrages and bunds, right? But we've got to be really careful not to negatively affect important species, because a lot of the created wetlands are now really important habitat for migratory birds, for example. So there's some real things to think about there. We'd hope there'd be sites that are culturally important, that the Indigenous people of Australia would like to restore. We're expecting that there are places that have really low returns on the current land use. So Fail and Cane, for example. We'd expect that the best sites are probably adjacent to intact systems so that we can have fish migrations and all manner of other things so that we're connected, and that would also improve water quality of the Great Barrier Reef, for example. And then we might want to also think about places that are really badly affected by freshwater weeds that if we introduce the salt water, we can actually get rid of them without spending a lot of money on weed control. So there's a whole bunch of things that we can think about in terms of opportunity. So this is an example of an early project. This one is from South Australia, where they have reconnected a salt pond, right? So it was, separated from the tide to produce salt. So they've reopened it. 3 years later, they've got, the start of the salt marsh, right? So again, another nice example of feasibility, really. And then some work that I've done with one of my postdocs is to look at opportunities. It's a cost-benefit analysis based on agricultural production versus potential income from carbon. And we identified that currently, probably in this wet tropics region, there might be about 5,000 hectares that might be available, but they're spread over many sites. So this could be a problem for scaling, if each individual landholder has to do this. But maybe there's more than that. There might be 10,000 if we get a higher carbon price. We did this analysis at $14 a tonne for CO2, but it's likely that people will pay 30 or more dollars a tonne if there's other benefits like fisheries or endangered species. So at the moment, we're working on adapting that kind of cost-benefit approach to other regions. So the sorts of places we're looking for are the historically drained and funded landscapes. It's actually very interesting, because I was really interested in your map collection, because a lot of these are actually quite hard to find because they happened in the 30s. Like after the war, there was a lot of machinery left around, and a lot of it was by, the Americans, for example, in North Queensland. And a lot of that was deployed to dig canals and dig ditches to drain the landscape. That's what happened to the Babinda swamp, right? So, in Western Australia, they have 5 drainage districts. In Victoria, they're spread around the place, but there are a few that are coastal. And then in New South Wales and Queensland, this is what it looks like. So this is before drainage, and then this is after, And on the Queensland globe, you can actually look at canals, and it has a map of all of the canals, the major ones that have been dug in Queensland, And I think in the wet tropics, there's like 200,000 kilometres of drains. It's huge, the works that went on. So they kept doing it right up until the 90s, basically 1990s. Okay, and then this is the final example I've got. This is an example of a ponded pasture at Mangala Station, which is just to the south of Hinchinbrook, where this was a big bond. The bund is here, and a big freshwater system that was tidal. It used to be connected to Cassidy Creek. And the traditional owners opened that bund wall, and they did it not for carbon, but they did it for weed control, because they were sick of having to spend thousands and thousands of dollars taking out declared weeds. And so I think this is another example of, feasibility, and there might be still some work to do here that might end up as a carbon project if the owners are interested. But they now do some cattle, and they do tourism, mainly associated with birds that are in the wetlands. So finally, this is my final stage, and this is some mapping opportunities for restoration. And this is new maps of wetland change that's been done by Nick Murray up in James Cook University. So these are huge machine learning exercises. So he's done this globally, and you can see that he's mapped the tidal wetland distribution, whether it's a mangrove or a tidal flat or a salt marsh, and then he's looked at gains, losses to these different ecosystem types, and also over years. So if you look at this, this is a green patch. It's a gain, ecosystem type, and change year. Basically it's a tidal flat with a bit of mangrove, and then you can see that it started to grow in 2004 and even to 2019, right? So it's amazing mapping that he's managing to do on the Google Earth engine, right? And he's actually started to do this now for the salt marshes of Australia. We don't have a map yet, and he's going to make us one, which is pretty fantastic, you know. And this is the outcome of the maps. So these are the different years, and below the line is losses, and above the line is gains. And you can see, and this is the mean change. So we're still losing coastal wetlands across the board, right? They're still on the negative side. And for example, this is the mangroves lost and the mangroves gained, because there is restoration happening and natural processes that lead to gain. But, you know, you can see that that process is still, this is 2019, so we still haven't done enough work to stop basically attrition of the ecosystems. All right, so here's my conclusion. Coastal wetlands simultaneously provide mitigation and adaptation to climate change, which means that they're well worth conserving and restoring. Blue carbon, the payments, and particularly, you know, if you talk about payments in Australia, can provide incentives to conserve and restore coastal wetlands. They don't have to be payments, right? You can do it in other ways, but it's a way of providing incentives. And I would say we still need some, you know, research and development to help with financing of restoration. You know, further develop guidance based on our new pilot projects and things that are going on to work out how to restore better. Strengthen local science on the value of the adaptation and the other co-benefits, like, you know, fish and all these other things, so that we can value them better, so we can make better arguments about the value of those ecosystems locally, not just sort of in this general sense. And with that, I think that's it. Thank you. Look at those while we do questions.
Thank you so much, Catherine. Fascinating talk, and certainly a fascinating area for further growth. So we'll throw to the floor first for any questions you might have. And William, let me know if any pop up. Chris?
Okay.
Sorry.
Didn't have my hand up, but I'll ask a question anyway. I'm very interested in this terrible development down on Moreton Bay, which is taking away a whole lot of coastline, you know, bird sanctuaries and all that sort of thing. Do you ever get consulted on by the government or anybody else on what they're doing, what damaging is happening there?
Yeah, there's a lot of concern about Toondah. You know,
Toondah, yeah.
Toondah. I mean, Moreton Bay, it's a marine park, one, and it's also a Ramsar wetland reserve, right, which is particularly important for the birds. So yes, you know, I do, you know, talk to a lot of different groups about those sorts of developments, and most of the time, you know, personally, I, you know, don't think we need it, but, you know, like others say that we need economic development in the Wetland Shire. It's really a societal kind of discussion about the value of those systems versus the economic development, you know. I mean, yeah, it's complicated, I must say. So the thing is that the thing is that if they do the, so no, it's like a war. It's like a whether we're going to go with death by 1,000 cuts, because everybody says down there, and it's true, there's no endangered seagrass because there's other seagrass in the bay. There's no particularly endangered bird that's right there, right? The birds are migratory. They'll, you know, find some. But the truth is that we've lost a lot of habitat in the bay anyway. And, you know, I mean, personally, I wouldn't recommend that we lose any more. You know, I think the second runway was controversial enough, right? I mean, that took out quite a lot of the habitat of the bay. And the other thing I think I'd say is that it's very hard at the moment to say one place is more important than another. But I think we should think a little bit like that. It's like old mangrove forest is, you know, that in, let's say this is about the airport, but the mangroves in Moreton Bay over time have stayed about the same area, right? We haven't lost a lot because we've gained a lot. We've gained a lot because there's been sediment coming down the Brisbane River and making more habitat, right? It's muddier now than it ever has been in the past, right? The system's muddier, mangroves like mud, we get more mangroves. But the older stands, you know, the big old trees and that kind of stuff, that's what's been removed. And they're not equivalent, right? An old forest that has big trees and habitat for things like microbats is not the same as a very young forest that has small trees, no habitat for those other kinds of animals. But it's really difficult from maps to get that information. And that information is not really there for you know, a lot of the ecosystems in Moreton Bay. So it's hard to make those arguments, you know.
I was just wondering whether you've heard recently, and I was just concerned that this might happen with Toondah Harbour, that some years ago, or maybe, well, they probably do it now, but if a developer goes and destroys a certain, you know, pristine ecosystem, they get approval to do it, and then they get told, well, because you're destroying that, you can go and restore this whole other area.
Yeah.
Do you think
it's an offset?
The offset, yes. Do you think that's likely to happen in Toondah Harbour?
I don't know. Honestly, I don't know that much about it. I've been distracted by other things like the blue carbon method, and yeah. So I don't know about what they're going to do with that. They would have to, I would think.
Oh, yeah.
If they have to approve it, then there'd have to be offsets.
Yes.
And then, but you know, like I say, you know, is it like for like? I mean, there's a whole research group at UQ that works on offsets and whether it's really a good strategy or not, you know. So, but they're there nonetheless.
Yes.
Yeah. So,
are there any opportunities for citizen science in this area?
oh gosh, we were having a big conversations about citizen science before. I don't know. I haven't really focused on that aspect. I mean, we've had a lot of discussions actually with my international colleagues about citizen science. And I think there probably is within restoration projects, you know, because there has to be quite a lot of verification. And, you know, like you can have scientists and small bands of scientists, like the Blue Heart Project. We're going up there, you know, every couple of months. We make all of those measurements. There's another team from the University of the Sunshine Coast that measures fish and birds and stuff like that. And I think there's room for the community to be involved in that kind of thing, for sure. Right? But, you know, you'd have to be really well designed for it to give data that would be useful, right? I see that's a problem with citizen science.
I think there is a group that does something about mangroves.
There's Mangrove Watch.
Yeah.
Yeah, their community group. They watch. They have a whole bunch of groups around Queensland, and they follow a particular protocol to monitor. And mostly it's about shorelines. So they do videography along creeks and that sort of stuff. And I think these kind of projects are going to be less like that and more. You know, like they're going to be, different kinds of access, I guess is.
But is the Mangrove Watch of any use to you? Is that in any way?
Maybe I haven't actually even thought, you know, like, because most projects, I'm not going to do the projects, right? It's the Sunshine Coast Council and how they choose, or Unity Water. You know, Unity Water pays consultants to do their monitoring, right? And Sunshine Coast sometimes pays consultants as well, or they engage with the university. But they could engage with the community if there was a method, if there was a protocol, if there was a way to generate data that unskilled, you know, that's the whole thing, you know, about identifying certain things. But certainly birds, geez, there's more experts in the community than, you know, like, woof.
Thank you.
Yeah. We have those crazy twitches.
I was going to suggest the Seagrass Watch.
Seagrass Watch is also another group that does wonderful work. Yeah. and they've had a very strong presence in Moreton Bay over the years, generated some fantastic water,
But
fantastic
people
data.
still go and pump the abbeys in the seagrass,
Yeah,
break it up.
yeah. People are the hardest thing to manage. The ecosystems are actually pretty easy, really.
Why does it be okay for no people?
Well,
But you know, that's what I said about capacity building and education,
Yeah.
because it's really important. Otherwise, you know, if you don't have everybody on board, and then, you know, like for the salt marshes, for example, some of the biggest damage of salt marshes is trail bikes, quad bikes, you know, that kind of stuff, right? And what happens is it gets churned up, and then if it doesn't recover, the mangroves are, it basically facilitates mangrove encroachment onto the seagrass, onto the salt marsh, which is the biggest cause of salt marsh loss at the moment. You know, 50% of the salt marshes in Moreton Bay have been removed due to urban development. And so we've only got 50% left. And, you know, like there's all this damage to it because of like just casual, you know, damage, right? And it's because people really don't know, well, they don't care because they don't know they should care, you know? So it's actually a long haul upwards in terms of education, I think.
What about the effect of the mangrove, the co-benefit of having the mangrove to take out the soil, the salt from the sea air before it gets to pasture further inland?
Mostly I would say that that's less. It's more that they basically can enhance infiltration. So when you've got, you know, like there's all this sort of roughness about the mangrove, so floodwaters moves more slowly. You know, everything gets slowed down. You know, and if you're a yachty or you know people who sail, you know, during a big storm, most of them take their boats as far up the mangrove as you could get them, you know, because it's much safer in there, right? So it's just it's that kind of service. And the other thing is that roughness actually slows the salt water, the tidal water getting into the real land, right? So you can actually like attenuate the tide by having coastal wetlands.
But I was wondering about the salt in the air, the leaf matter catching the salt. But looking at these pictures, I can see the leaf is, you know, you've got all that salt air coming across.
Yeah, I don't think that would so much. Yeah, this is Nudgee, right? Beautiful Nudgee, such a lovely place.
We do have one quick question from online, and we'll throw back to the floor from Len Lowry. If farmers get on top of their sediment loss, will that affect your models of sediment gains in foreshores?
Yeah, it could. But a lot of the sediment that's out there, like, for example, rolling around in Moreton Bay, arrived a while ago with land, you know, when they cleared the catchments. So a lot of the time the sediment's already lost from the land and is within, you know, coming out the river slowly, right? So it will make a difference when, right, you know, fixing the riparian zones of the Queensland creeks and rivers would be a big benefit to the Great Barrier Reef. It's pretty simple, you know, and but a lot of the sediment has already exited. So maybe, but not in a while, I would say. You know, mangroves and salt marsh are really good at making their own soil volume as well. The roots actually, you know, that's how you generate peat, right? And so, you know, like that actually can contribute 3 to 5 millimetres a year themselves. So the mangroves in Belize, for example, they're islands that are sitting on 10 metres of mangrove roots that are just sort of been made over time and haven't decomposed. And those islands have kept pace with sea level that way. There's no sediment in that system. It's a coral reef, right? So it's all just mangrove roots. So they're productive enough that they can actually do quite a lot of elevation gain themselves.
Any final questions from me? All good.
Well, we might wrap up there for tonight. And just a small token of our appreciation. Thank you so much for coming in tonight.
Thank you.
A very fascinating topic. I'm sure we'll be watching this space closely, particularly in the next few weeks with the COP26 discussions and what will come out the other end of them. So
I'm going tomorrow.
even better.
I'm going to
So-
Glasgow tomorrow. Really? Yeah.
Oh,
Yeah.
fantastic.
Well, thank you for coming to see us tonight. Then.
Yeah.
Another round of applause, and then our wonderful tea and.
So I just get